Hello everyone and welcome to this second session of hands-on deep learning with MatconvNet. So in this second session we are going to talk about how to do training. We're going to go through the training code in order to understand all the peculiarities, how everything is working. We're going to see also how to do the forward pass and the backpropagation. So first thing as usual is to call VL setup NN in order to enable MatconvNet, so basically to put everything within the path. Okay, now we have defined this example using BGF. So this is a quite famous architecture too, so it's causing of BG Predip 16 and BG Predip 19. Well, it's just a good example to start seeing different sort of architectures. The idea is to work with CFAR10 again, because it's small enough to run it in CPU, but it's also big enough in order to do something meaningful. Well, if you remember from the last session, we defined AlexNet and LeNet. This architecture is quite similar to AlexNet, but it doesn't do this thing of the double flow. So there are no two flows in parallel here. So you can see that the number of filters in each convolution matches across convolution. Okay, 64, 64, 256, 256, 256. 256, and so on and so on. Okay, it's worth noting that I'm not calling the fully connected layers as fully connected. I'm just calling them convolution, because as we said in last session, fully connected layers are just convolution layers. You can see the architecture is pretty much the same as we saw last time in AlexNet, well, just with a couple of peculiarities. So we have two initial blocks composed by convolution ReLUs, local regularization, pooling. Then we have two blocks composed by convolution ReLU. Okay, just activations. Then convolution ReLU pooling and convolution ReLU dropout. So when we reach the fully connected layers, when our output gets larger, we start adding dropout. So probably many of you are familiar already with the effect of dropout, but in case you don't, please check the additional resources we provide with this course to learn more about how dropout regularize the train of the network and try to avoid overfitting. Here we define dropout through a rate of drop, in this case 0.5, so half of the connections are going to be destroyed during training. During test, dropout is going to behave just as like pass-through filter. Okay, the same happens for the next layer, and then as before we have a classifier, softmax, and our loss function cross entropy, and a second loss function just to compute some statistics of our network, basically a classification error. The initialization is still the same as in AlexNet. This has been pretty much a copy paste. Now let's gonna try to run it on MNIST. IMDb MNIST sorry, CFAR10 micron. Probably for your case the path is gonna be a bit different. so don't follow the exact path. Okay, now I have to call this and the magic will happen. So the experiment name, something like output VDF experiment 1. Okay, let's go. Oops, something went wrong. Oh my god. So I think we're gonna need to debug it. We're gonna need to understand a bit better how MatconvNet is working, like behind the curtain. So why don't we do that?